In this set of videos, we will explore Eagle PCB, a design tool for printed circuit board design. We will see how to make a schematic, a layout, how to finalize our design, and also how to make a custom component. In this video, we will focus on the schematic. For our example, we will be designing a breakout board for a camera module. A breakout board is a useful hardware tool. It gives you access to all the pins of a package that otherwise would be inaccessible. When you have a through-hole dual inline package, you are often able to put that directly in a breadboard and therefore prototype easily. However, if you use surface mount components, this will not be the case. We will make a breakout board for the OV2640 camera module shown here. As you can see, it would be extremely difficult to test this module without some kind of interface. Its leads are right here and each one is very small. You could potentially solder a wire to each one of them, but that would be a huge hassle and it would be much better to design a breakout board. So let's take a look at starting a new project. When you first open Eagle PCB, you will see something like this screen. I already have a lot of projects, you will probably not see these. However, you will see something similar to this. So the first thing that we're going to do is start a new project. So in this folder, I'm going to say new project, and let's call it OV2640 breakout. Then to this project, I'm going to add a new schematic, and we're not going to name that quite yet, and this is a screen that you're going to see. So the first thing that you usually want to do with a schematic is import some components. In order to do that, we will click on this button right here. It says Add, and this will take us to a screen that looks like this, which lists all of our possible libraries, and we can pick any one of these libraries and import some components from them. So the first component that I'm going to import will actually be from my own library, and that's going to be for our camera, and specifically I'm going to choose this component right here, and we'll go over how to make custom footprints in a later video. However, many common footprints are already available as long as you know which library to look in. So this is what this is going to look like, the connector for our camera, and I'm going to place it right here. And when I hit escape, it takes me back to this screen right here with all of our libraries. So now I'm going to import some more components that we're going to need. Specifically, I'm going to go to the SparkFun library, which is readily available online, and I'm going to import a resistor and a capacitor because I know we're going to need those. I'll show you why a little bit later. So here I scroll to Cap, and I'm going to use surface mount components, specifically an 0805 package, and so I'll just throw one in right here. Again, hit escape, scroll down to resistor, and let's pick out another 0805 package and put that right here. And since we're making a breakout board, this is going to entail having some headers on the side of the board. And again, having done this before, I know what size headers I'm going to need, but in general, you're going to basically see how many pins you want to actually access and base your headers on that. So I'm going to take, and these are the headers right here, the M headings right here. I'm going to take an 8-pin header, and I want to make these nice and easy to access, so they're going to be pretty large. They're going to be regular through-hole components. So as you can see right here, this shows you its symbol, and this shows you its layout, its footprint, and you can see that it's just 8 holes side by side, each one of them spaced by 0.1 inches, as it says right here, a standard 8-pin 0.1 inch header. So this kind of thing can be put into a breadboard, for example, if that's what you choose to do. So I'm going to pick this, and I know I'm going to need 2 of these. And I also want a 2-pin header. So again, just regular through hole. You can see they have a lot of different types of 2-pin headers. And if you look through them, you can see how their footprints are going to differ from one to the other. And so I just want a typical 2-pin header. And so I'm going to take this. I'm going to need 1 more. And then I want also a 3-pin header. I'll show you, of course, how we're going to use these as we start actually designing our board. Okay, so I've got these headers and a couple more things that I like to include. First of all, I like to include a supply rail. So specifically, I want a power and a ground rail, and so I can go here to this supply 1 library, and what I will choose is a ground connection and a VCC connection. Again, there are many different choices. I just have used these before, so that's what I'm going to use here. Now, one more component that I'm going to include, and this is from knowing that I'm designing a breakout board for this particular camera, is going to be a voltage regulator. Now, this particular camera has technically 3 separate power supplies, and 2 of them can be fed by the same voltage, but the third one cannot. Specifically, it needs something like 3 volts and 1.2 volts. Well, before I had already designed a voltage regulator just for this kind of a purpose. So again, I'm going to go back to my own library and pick out this dual voltage regulator that I had already designed. By the way, I can rotate components by right-clicking. I have been doing that, and also you may have noticed I've been scrolling around this schematic, and I do that by holding down the center mouse button and moving the mouse. If I just roll the mouse wheel, it will actually zoom in or out. So to move around, hold it down and move. So I'll place this right here, and actually there is one more component that I would like just to make this a nice breakout board, and once more I'll go back to the SparkFun library, and it's going to be a jumper. Now a jumper is nothing more than just a 2-hole connector once more, but it just has a nicer look for what we're going to use it for right here, and I'll show you this in just a little bit. Okay, so now we have all the components that we need for our camera. So I can exit out of the interface to add components, and let's take a look at our schematic. Now, to make actual connections on our schematic, we're going to use the wire tool right here, or the net tool. And so to do that, we start at the edge of a pin, and we trace our wire here, and let's say we want to connect it to D2 over here. So I click to set it down in a place, and then I can keep on tracing. You can see it bends automatically, so if you want to be precise, just keep on clicking at various locations, and you can do whatever you want. Make it look however you want. Of course, this is not how you would do it, but just to show you an example. And when you click at an actual connection point, the net will terminate, and you can see that I'm no longer dragging it. It's going to stop automatically. And so now you've made a connection from pin 8 of this first header to the D2 connection on our camera interface. Once you've made a connection, it is connected to that component. So if you try to move a component, and to move a component you click on this button up here, the move button, and you can select a component and move it anywhere, and you can see that that connection stays with it as you do that. And same thing with this one over here. And so we can keep on going and wiring all of our connections. Let's say this one goes here, this one goes here, and you can do that. But you can see that as if you try that, your schematic is quickly going to get messy. Of course, I made it messy here on purpose, but you can see that it's going to get messy. And there is a nicer way to do this, and that is by labeling. So let me show you what I mean. First, I'm going to clear these wires by clicking over here on this button, delete. And if I delete this, well, I can delete it by segments, and you can see if it's complicated, it's going to take quite a while. I can also automate this process a little bit by selecting more than one thing, and so I click on a given thing that I want to do, so here delete, and on this group, and then if I highlight this area after I click group, it'll highlight all of these wires, and if I right click on that, it says delete group, so it reverts back to the previous command that you had selected. Another example of this would be if I want to move several things at once. I click on move, and then I click on group. Let's say I group all of these together. Again, right click, move group, and then I can move this around. So you always want to click on the command that you want to perform, and then group in order to be able to perform the command on the entire group. Okay, so when I say that we can wire by using labels, here's what I mean. Instead of connecting things directly, I can make just a short wire here, and I terminate it by double clicking. If I click twice in the same spot, you can see right now with one click it keeps on dragging, but if I click on the same spot again, it terminates. So I can make these for all of my pins right here if I want to. And then what I would do is I will select the name tool and I click in a given wire and then I can name it. So here, let's say I'm going to name it D1. This one I'll name D2. And this one I'll name D3. And finally, let's say this one is actually going to be AVDD, so one of our power supplies. So then you're not sure which one is actually which after a while because they're not labeled. So one thing you can do here to make this easier on yourself is click on this tool right here, the label. And then if you click on this, you can actually place these labels associated with this wire somewhere where it's going to be helpful to you. So let's say like this, and again I click on each one and it's going to show what it's named. Now to make a connection using this, I would once again, for example here, make the same kinds of wires. The length doesn't really matter. I'm making it kind of arbitrary just to illustrate this. And where's my AVDD? One of these is AVDD and the other one is going to be DOVDD, so two of the power supplies, but I feed them both with 3 volts. So on my component, I just labeled them both with 3 volts. Alright, so then what I would do is I would do the same thing. I would once again name these. So I see this one is called D2, so let me call it D2. And now Eagle is going to prompt you, do you want to connect these two nets? Basically what I did was I just made a wire, which is just a net, and it automatically got called $3, and the net D2. So I renamed it to D2. Do I want to connect these two things? So when I label things, I create a net of that name. And so I say yes, and now these two things are electrically connected. And the same thing I can do here. This is D1 and I connected. This is D3 and I connected. And finally right here, AVDD, and once again I connected. And now I can label these just like before. And these things are now electrically connected. And we're going to see this a lot more clearly in our layout once we get there. But this is how we're going to make our labels, just to make them look a little bit nicer. Now this is not necessarily how I actually want to label these, so let me once more erase these. And continue with the explanation. Now let me tell you why I have all of these different headers and components. So these 8-pin headers are going to be for the various signals that are coming out of our camera and going into it. A 2-pin header here is going to be for the I2C interface, so for the SDA and SCL signals. This 3-pin interface is going to be for our 3 power supplies that we're going to need, AVDD, DVDD, and DOVDD. This header right here is going to be our power supply, so it's going to be our input power and ground. And then for our voltage regulator, what I'm going to do is I'm going to make it an option for the user to either provide his own power supplies or to use this, and that's what the jumpers are for. The jumpers will let you select whether you want to use the voltage regulator's power or your own input power, just giving the user more options with this breakout board. Now, the capacitors and resistors are going to be used for our components here, so specifically the capacitors will be used for the power supply for the voltage regulator because it's going to need some capacitors. And the resistors are going to be used for the I2C protocol because it needs to be pulled up. So that's just a property of the I2C protocol, and that's what we're going to use that for. Now you may notice that I only made one copy of each one of these. And so you may think, well, now I have to go back to the library and get more of these various components. But there's a nicer way to do this, and all you really need is one copy because you can go up here to the copy tool and click on any of these, and you're going to make a copy of it directly. And then you can use that as much as you want in order to make more of these components. So let's start actually wiring here a little bit. So like I said, some things I want to label, some things I'm actually going to wire directly just to make it a little more clear, and because it's not that complicated to make that wiring. So the first thing I'm going to do is for our general power supply, I know that it needs just to have power and ground. This is the headers that go to the outside world that will allow the user to plug in a power supply, and so I'm going to wire them up very directly, just like that. So now we have a header that's going to be our general power supply and ground. Now I'm going to wire up our voltage regulator. It has two enable inputs over here, and I want it to always be enabled for the purposes of this, so I'm going to just take our VCC to rotate it, again right click, and I'm going to connect it directly to here. And then I'm going to make a copy of this and put it on the other enable signal. And also there's an input to this power supply, and that's also going to be the same net, the same VCC that comes from my input to this board. There's also a ground pin and two outputs. Now, as I said, this camera takes 3 voltages, but 2 of them can actually be the same, and I'm going to provide them with the same one. But again, it doesn't have to be, and optionally, I want to give the user the opportunity to provide all 3 different power supplies. That's why I'm going to be using these jumpers. And so the first output here is going to be 3 volts. And I'm going to wire that to one of these jumpers and also to the other. So these 2 are going to be 2 of the power supplies. And then I'm going to wire the second power supply here, which is going to be 1.2 volts, to this third one. And so then, to actually show what these outputs are going to be here, and to make these nets proper, if I connect these jumpers, that is, if I just short them together, that's what a jumper will allow you to do, either short or disconnect. If I short them, then these lines right here are going to be the actual power supply. So let me label them. And so first I'll place these labels, and then I'll title them. So you can see for now they're just generic names. But then I again name them, and this is going to be my DOVDD. This will be AVDD. And this will be DVDD. Okay. Now also, this power supply is going to need some capacitors in between the various pins. And so then what I'll do is, just to make this a little more compact, I'm going to actually place them on the inside of this component. Now there's nothing wrong with doing that. So I'm going to do this, and it needs 3 capacitors. One here and another here. And so then once again I have to connect to the same thing right here. So this needs one between this output and ground. So then I'll place this over here and to ground. And it needs a capacitor between the second output and also ground, and also between the input power supply and ground. So now it's all connected with 3 capacitors. Now it's also a good idea just to keep track of what the values of these capacitors will be, even though in reality they have just a given footprint, an 0805 footprint, so you can put any capacitor you want as long as it comes in that package. But just for your own sake, it's a good idea to keep track. So you'll click on this button right here, value, and if you click on this capacitor, you can assign it a value. And in this case, from the datasheet of this power supply, of this voltage regulator, I know it needs to be 1 microfarad, so I'll label it as such. And you can see that label appears here. And so then for this one as well, 1 microfarad, and this one 1 microfarad. Okay, so now it's nice and labeled. And also, just for good practice, it's not a bad idea to put a bypass capacitor in between your power supply actually here. And I'm going to make this one a little bit smaller. This one I'm going to make 0.1 microfarads. And I'm going to connect that once more between power and ground. So here to here and here to here. Okay. So that's our power supply section. Oh, I guess I also forgot one part over here. I need a ground on this pin. Okay, now we're set. So now comes the labeling of all of these various inputs to these 8-pin headers. And let me go through that kind of quickly right here, but try to keep following along. Okay, so now I've labeled all of the connections that we have, and actually a few more. You may notice that a couple of these are labeled as no connection, but I connected them anyway. I label these as no connection on my device because I don't use Y0 and Y1 and also IFEN. But just to make this a complete breakout, I'm going to include those as well. And so now we have all of our various pins on the camera broken out. So now a couple more things just to make this a bit nicer, and that's for the interface. I want to also have breakouts for the SDA and the SCL with pull-ups. And so here, let me again make this the same kind of way. A separate header here. And so these I'm going to call SDA and SCL. And finally, potentially we want to be able to provide our own inputs to the power supplies instead of using the ones that are coming out of the voltage regulator. So I'm going to make a header that's going to allow us to do that. And so here this is going to be one of our power supplies, AVDD, DVDD, and also DOVDD. And once again, let's label those here. And that's pretty much it. And one more thing is now I could directly connect my resistors to the SDA and SCL pins, but just to keep them a bit separated here, what I'm going to do is I'm going to, and again just to emphasize the role of these nets instead of direct wire connections, I'm going to have them be separate, and so they're going to be right here, and I want to have a pull up on SCL and SDA. So I'm going to make this net right here, and I want it to be pulled up, so it's going to go to a power supply, specifically DOVDD. And so this is going to be DOVDD here. And one of these will be SCL, and the other SDA. And so again, just to make this nice, let's place these labels on them. One more thing we want to include here is actually some values for these resistors, again just to make it nice and proper. And so two values that I use here are going to be 3.3K for each one of these resistors. And that is it. That is our schematic for this breakout. In the next video, we will see how to make a layout out of our schematic.